Ako sa YouTube, sige. Dali kayo.
For 1 year, ako pala yung curse. Hello. Okay, good afternoon. Okay, apology our professors. Okay, hi everybody. Hi grad students. Hi undergrads. Hi undergrads in Zoom. You're lucky because you're in Zoom because the place is packed. You couldn't have gotten in if you were late, so let's go. Ay, wait, narinig ba? Ay, dito
Med-
mic. Hindi kasi dun yung cam eh.
Medyo ko-observe.
Ano di? Narinig ba yun, pre?
Hindi kasi yung mic talaga nandun.
Dito talaga.
Yung mic kasi ikaw yung naka.
Yun yun.
Bakit narinig tayo?
Okay, nag-green naman. Okay. Okay, introductions aside. Hi everyone, good afternoon. Tess na. Game na. Alright, so welcome to the Microlab Apps OR. Ito pang org. Apps OR. Alright, hi everybody, good afternoon. So introduction lang on what we do in Microlab. So all things considered, okay, sige. I'm Ralph. I'm 2019, which means I graduated in 4 years, and I'm Microlab, so make of that what you will. Alright? So, okay. Okay, here at Microlab, we make big systems small. So how does going small benefit us in our technology? So going smaller gives us more space, lowers the cost of our components, allows us to integrate our systems, and cool things happen in the micro scale. Okay, so this is one of the times when being small isn't that bad. So next slide. Ay. Yun. Ginawa namin, hindi ba namin? So here's a rather crude example. Okay, relatively crude example on how turning relatively large systems smaller benefits us. So we have this is a weather monitoring crossbow mode. So it's roughly like what? The size of a phone. And then what we do in Microlab, with my dear group mate from our last undergraduate project, we designed a really tiny sensor along with its interface circuit. So there's like a speck of dust inside compared to the crossbow mode that's like the size of a phone. So that's what we do in Microlab. So di ba mind-blowing? Something this big, tas kailangan mo na microphone to see it. So, yeah. Who are we? So of course, who are. Okay, introducing again our honored Microlab faculty. We have Sir Louis Alarcon. Ma'am Tata. Ma'am Tess. Sir Chard. Sir Mark. Sir Adel. Hello. Tapos, currently away finishing PhD studies, si Sir Chito and si Sir Ryan. Ito na. Our honored Microlab faculty. So si Sir Herlan, si Sir Fred, please stand for recognition. Hi, Sir Fred. Si Sir Arcel, si Cas Champion, si Sir Rafael Pangilinan, di ko alam yung relation niya kay Sir Renz Pangilinan, si Sir Lawrence Quidon, si Sir D, tapos si Sir Allen. Hello! Tapos yung Microlab faculty. Ay, hindi, faculty. Students na pala to. So this is a fairly recent photo. Kitang-kita nyo naman, masaya kami. So currently there's like 20 plus graduate students. Tapos yung undergraduate students, roughly 30 this sem. So they're all either proposing in 196 or currently ongoing sa 199. Tapos, ito na. History of Microlab. Which, okay, there's a Christmas tree and chip. Tapos, guess ko na lang yung ano dito, yung initials sa maligayang Pasko. So, yung sure lang ako si Sir Louie, LPA, tas si Ma'am Tess, TAG. Oh, Sir Hizon. Yan. REH. Tas the rest. Okay, moving on.
Sige, history.
Sub.
Sab.
Sige, sub muna tayo para sa history. Though it's not like I've seen this myself either. Hello again. So ako si Sir Lo. Hey, thanks. So in terms of history, no, back in around, well, you can see here, di ba napag-usapan natin ang IC design, right? We make things smaller, and actually successively over the years we managed to make things much smaller, no? Though this is not particularly, it's not like us particularly yung ano, di ba? May credit dito, but you can see here, no, 2 micrometers yung una, that's 10 to the minus 6, no? Tapos naging by a decade after, it becomes 350 nanometers, no? That's 10 to the minus 9 na, and then it becomes 90 and then 65. And in fact, right now, no, if in Microlab, no, you can get the chance to work with 28 and 22 nanometer technologies. So, ganun na kalit yung wino-work natin ngayon. Though, some of you who are very interested in computer processors may know na ang ginagamit na ng mga processor natin are something like 2 nanometers, no? From Intel and such. Kaso tayo, 22 tayo. Well, academic naman tayo, we try to work with you know, what we have and what's pasok sa budget in essence, right? So, recently, no, though not so recent anymore, so these are circuits that Microlab itself has fabricated, no? So we have the 65 nanometer low voltage test circuits, so we can, I'm not sure kung tinake out talaga to, like kung bumalik siya. Kaso, basically, part of Microlab's mission really is to design circuits that use really, really low power. And the thing is, when you use very low voltages, you basically accomplish that by a lot. No? So we want to make circuits that to test whether or not our low voltage design principles actually do work. Right? So ginagawa natin yon. And back a few years ago, correct me if I'm wrong, kaso 2012 yata or 2012 to, the 180 nanometer mobile robotics controller, microcontroller was a collaboration with Mobile Robotics Laboratory of EEE as well. No? So for those of you who know Sir Adel now, no, that's actually Sir Adel's hand holding the IC, no? More than a decade ago. So, okay, sorry, Paul. So you can search in Facebook to see yung post na yun. I think kung hindi naman naka-private, but apparently it's in Facebook. Tapos there's also low voltage error tolerant microprocessors. Apparently this is called Razor, also courtesy of Sir Adel. And a phase lock loop, no? So PLL, this is, I think, the only analog that's here. I'm not sure kung analog yung 65 nanometer na the voltage test circuit. But I'll note no that you can also see kung alin yung nauna at alin yung mas later dito sa mga to by the size, no? So, in general, no, yung mga processor projects natin is made up of a lot of different subparts, no? So, actually, in Microlab, there's a potential for immense collaboration because each of these chips contain a lot of different blocks that one person cannot make on their own. So, for example, IC here has a lot of different sub-blocks. You have the controller, you have the core, you have the interfaces, I2C, SPI. Pretty sure some of you have already encountered these in your classes, no? Analog parts like the DAC interface and the power management part. So there really is a lot of potential for collaboration in Microlab, and your group mates can you can have as many group mates just depending on your topic as you may want, right? So in terms of that, I will give it back now to sino dito? Raz ulit. Sige.
There you go. Okay, so so to cover the current and the past projects na usually DOST funded or some funding agency that's operated in Microlab. The current projects are CARE. So it's the Center for Air Research in Urban Environments. So yung project dito dyan si Sir Chard. Tapos for CIDR naman, it's the Center for Integrated Circuits and Devices Research. So yung mga project dito dyan sila Sir Louis, Ma'am Tess, and Ma'am Tata. That was for the previous projects. There was Renz. It's about resilient sensory swarms for energy and environment monitoring. Verse, which is about preparation of energy harvesters for resilient sensor nodes. And SPICE, which is smart plant production in controlled environments. Tapos now for a brief introduction on CIDR, may we call on Ma'am Tess to briefly introduce.
Ang yung visual side. Ito po yung last year din. Reuse lang.
Okay.
Yes, Adel.
All right. Good afternoon, everyone. Okay, so nautusan ako ng mga graduate students. Anyway, all right. So basically CIDR, Center for Integrated Circuits and Devices Research. No? So siguro just to give you a brief background, before kasi Microlab faculty members has had research projects that focus on different things. So one is we had research projects really focused on manpower development. No? So ibig sabihin, tinatry namin na matrain yung mga faculty members from other universities so that they can also offer microelectronics courses in their undergraduate curriculum. Okay, so yun yung isang set of research projects that we were doing before. And then secondly, we also had research projects that's really focused on basic research, fundamental research. No? So pag yun yung ang output is yung mga test chips na pinakita ni Ralph and Lawrence earlier. Now, right now, no, so we're at this point that when we were trying to think about yung next na research project that we would want to venture in, we thought that maybe it's about time that we focus more on the graduate level curriculum as well as engaging industry and other academic institutions in our research projects. So kaya dito pumasok yung idea that we now look into, if you notice here, no, the key point inside there is joint development. So even before we design the circuits, no, we try to engage industry partners, government agencies, other academic institutions. So we invite them to join our research meetings. Some of them, kasi ang CIDR is already on their year 2, so some of the companies, for example, have expressed interest in, let's say, allowing or volunteering one of their engineers to be immersed in one of the research projects. So mas ganon yung tinitingnan namin dahil we think that it will enable the industry to absorb yung technologies that we are developing here in the academe. Kasi yun yung gap na nakita namin. So we're trying to, before kasi nangyari lang is we do these research projects, we graduate students who are very good in integrated circuit design. And ganun lang, no? So parang nag-feed lang tayo ng manpower to industry. But I think now, medyo nagmamature din yung IC design industry dati, and that we think that maybe there could be some mechanism that we can also invite them, no, to look at the technologies that we're developing, the methodologies that we're doing, and then maybe they can also apply that to their company. So kaya ganun yung nature ng CIDR. So the strategy therefore there, next slide. Yeah, so that if you notice here, no, so because before the technology push is that yung government fund, basically yung development it goes into this what we call valley of death, and then what we need is really for collaboration between yung government funding and industry participation in the research so that we could innovate further. Kasi syempre limited din naman yung capabilities nung iba't ibang sectors na yon. So nag-jump siya to anyway, so an example that we did before is some of the research projects before, for example, the SmartWire, it's focused on single chip power line wireless sensor node. So this was developed by a team of graduate students, and what they did is a proof of concept, no? So basically, can we harvest energy from the power line, okay, so that we'd be able to sense the health of the power line. So parang ganun siya. So by doing that, so they're basically asking questions, they're trying to solve problems, exploring ways to make this energy efficient. And at the same time, they actually developed several blocks, several aspects of the system. So they had energy harvesting, then there could also be some machine learning there, RF circuits, data converters, and voltage converters. So the master students who actually worked on this chip, some of them pursued further studies. Some of them are already designing actual chips sa industry. Another strategy of CIDR is what we call mirror labs. No? So what we think is since we want to basically grow the skills of graduates from not just from UP but also from other universities, then we want to also improve the graduate level curriculum of the university. So we still have, as part of CIDR, as part of manpower development, we offer joint classes, okay, so yung mga graduate classes ng UP, we actually offer them to not just academe, no, even those who are in the industry, even those who are in research agencies of the government, they're also allowed to join these classes. And then still, in parallel with that, no, we have identified some of the academic institutions might require our development first as an initial step in terms of our mirror lab, but some institutions are actually ahead. Some of them already have graduate programs, they already have faculty members, they have graduate students. And in those cases, the mirror laboratories that CIDR wants to establish are really mirror laboratories that will do research as well. So some of them could also immerse in the research projects that we're doing and eventually propose research projects also under the CIDR program umbrella. So basically, no, parang gusto naming i-grow yung community of IC designers and, of course, device researchers. So in terms of applied research, currently, the research projects that we're doing are really focused on wireless sensor networks or IoT, but the technologies there, let's say, RF, low energy, energy efficient RF circuits, machine learning, resilient na interface circuits, those technologies are still applicable to other application areas. So if, let's say, if the design RF circuits that have radiation hardening, then it could be applied in the area of space technology, etc. Yeah, so also part of the activities that we're doing is that part of the collaboration, kasi at the start of when we started with the CIDR program, there's actually these letters of support from different institutions. So part of that is that with industry and government RDIs, we actually have these design reviews for so that they could also provide feedback to our researchers on the designs that they're doing, as well as a technology conference. So this is an opportunity for the industry, other academic institutions, etc., to also see the circuits that our researchers are doing. So CIDR is actually composed of 4 component projects. So hindi na updated to, 22 nanometer. And these research projects, okay, 3 of them are actually hosted here sa UP Diliman, project 1, 2, and 3. While the last one, project 4, is actually implemented MSU IIT. So there's already this, parang yung core na CIDR na network is UPD and MSU IIT. But for mirror laboratories, okay, we have mirror laboratories. The main requirement is that they have at least 1 faculty advisor who's going to also work with us, and 1 or more graduate students. And as part of the agreement to become a mirror laboratory, okay, the CIDR program can also provide them with some software and hardware support. So yung mga licenses and some workstations and servers if needed. Okay. So the work plan of CIDR is as follows. So we started in last year, 2022 pala. So we started August 2022. It's a 3-year program. So we're ending in, expected is in 2025. But actually, what we're hoping for is that we continue, no? So this program continues. So we will still propose projects along the way that's under this program. So why is this relevant, no? But this orientation. Well, most of the undergraduate projects that most of the capstone projects that our students are working on are really on the things that we want to explore, the problems that we want to solve in these 3 projects under UP Diliman. Okay, so I'm not sure if there's going to be some discussion there, but today, basically the goal is that when you're doing a capstone project in a Microlab, okay, siguro yung batch nyo and maybe the succeeding batch, you're most likely going to be part of CIDR. Okay, yung mga topics na gagawin nyo. Yeah. And then eventually, what we hope to have eventually is that yung long-term dito is we want to have CIDR as a national center, no? Really focused on parang centralized, no, yung support for yung activities for integrated circuit and device research will be in that center. But for now, short term, as faculty members, what we can do is really propose projects under this main concept na collaboration siya and involving industry and other partners at the start of the process. Okay? Wala namang Q&A ito, no? Ayan. Okay, so yun lang. Most of the researchers actually, most of the graduate students are actually involved here. Siguro ngayon din it's an opportunity for me, no, na to siguro invite everyone na rin, yung mga students natin. Although magka-capstone pa lang kayo, siguro pag-isipan nyo na rin na eventually, after the capstone project, you might also want to go to graduate school. Say it's really different since it's going to be, you're going to be specializing. Kung sa micro kayo mag-specialize kayo sa IC design. So you'll really have more opportunity to learn and gain better skills and will make you more competitive sa industry. Yun lang. Thank you.
Good afternoon, everyone. I'm Anna. And just to continue the presentation, also one of the projects that Microlab is collaborating with is CARE, Center for Air Research in Urban Environment. So this is headed by Sir Richard Hizon and Sir Mark. So if you want more information regarding this project, you may approach them. Andiyan pala Sir Chard. Sir Chard, can we have an introduction regarding the CARE project?
Yeah, thanks. Let me start it.
Wala po.
Yeah. So ano lang naman to, commercial lang. So I think this was parang inspired by work that we did at Berkeley bago ng pandemic, where people from Berkeley were also working on systems and looking at how they can use this as test beds as inspirations for the next level of ICs na kailangan magawa. Now, yung CARE evolved into that in the sense that ang ina-address namin is something of a need ng LGUs and government on infrastructure to be able to capture yung data regarding air quality. And siguro yung maganda lang sa CARE, it was a vehicle, a platform on how we can collaborate outside of EEE. Now, within CARE, the project na inaanda namin ni Mark, marami din na outside Microlab working with us. But at the same time, it's a 3-project program kasi at the moment. May collaborate kami from ME, MA, ISM, chemistry. So maraming involvement yung mga tao, and we're learning a lot. And some of those na ginagawa doon eventually will trickle down as topics din papunta sa mga topics dito sa undergrad. But for now, dahil inaayos pa namin yung system, yung ibang mga topics definitely would be parang inspired from the CIDR na trust. Which in the end, rin naman yun, some parts of that, pag pinagsama-sama ko, pwede rin siyang gamitin for environmental application. So with that, kung may additional lang kayo questions, you can always approach us. But for now, it's really about CIDR. Thank you. Thank you.
Ayan. Thank you po, Sir Richard. So to continue, hoping that with the presentations presented by Ralph, Sir Lawrence, Ma'am Tess and Sir Richard, we were able to encourage you to join Microlab na nakikita niyo kung ano yung ginagawa namin in terms of the learnings regarding specific topics in microelectronics, and then sana nakikita niyo din yung practical applications and how we help the community, the microelectronics community, as well as yung overall applications ng projects na maaaring mag-benefit kahit sino. So, after that, now, let's start with yung 196 and 199 at Microlab. So, ito na yung sa tingin namin na kailangan yung i-focus since makikita nyo na, again, our main topic in Microlab, of course, microelectronics and the technologies that drive microelectronics. So, these are the topics that possibly you will explore, which includes sensors, computing, signal processing, communications, energy harvesting, and etc. From the graph that you see, there is the technology landscape per era that Microlab is trying to explore. So we try to explore technologies that are recent. This specifies yung mga technologies from 2020 to 2024. Given this, because of this, we want to take advantage of the opportunities given in this era. And of course, we want na yung capstone projects that you will do under Microlab are relevant and something na you can apply, like for example is yun nga nabanggit ni Ma'am Tess regarding the CIDR project. So in Microlab, you will learn different you will have to learn yung independent learning, wherein of course you will be reading technical papers and such as conference papers, journals regarding the topics that you want to explore, and of course applying what you have learned. This is with the aid, of course, ng advisors na I'm sure na hindi naman kayo papabayaan. And so here are the general undergraduate project topics under Microlab. So first one is yung robust and resilient circuits. By robust and resilient, we mean devices na that can perform well despite yung variations na pwedeng manggaling dun sa, let's say, manufacturing process or environmental changes wherein ina-apply yung mga devices. So under this, we have yung analog and digital computing or processing, as well as yung communications. And then we also have non-CMOS devices, where meron tayong spintronics, memory stores, and MEMS system, and MEMS, microelectromechanical systems. This will be explained further when we discuss yung coursework na required it take if you wish to be a Microlab affiliate and if you wish to explore this topic. And then we also have yung mga low voltage, low power, and energy efficient circuits. For this one, we know na there are certain applications that we want to have a long life. For example, when we have devices na gusto nating mapatagal, even though yung let's say yung supply niya is just a battery. And to maintain the long life of the devices, we need yung mga low voltage, low power, and energy efficient circuits. And of course, merong mga certain topologies for clock generators, references, memory, ADCs, and DACs na can handle this kind of performance. And then we also have yung energy harvesters, wherein we're trying to exploit yung energy in the environment na we can convert and use within the systems that we are developing. And this will also prolong the life of the devices, of these devices. And then, I guess for this one, design adaptive circuits, this is also mainly to contribute dun sa robustness and resilience ng circuits na i-develop. These are closed loop systems that we can develop to reduce the variations of the systems. And lastly, we have yung digitally assisted analog and analog assisted digital. Meanwhile, this improves the performances of the initial circuits that we have. For example, if we have an analog circuit, we can have digital circuits that will have the performance of these systems, and that is digitally assisted analog. Similarly, yun din yung sa analog assisted na digital. And of course, these topics are not normally taught in undergraduate programs, especially, I guess, on other universities. And also, given these topics, we were also able to have 30 plus international undergraduate paper presentations in the past 4 years. And to demonstrate that, ito yun naman yung mga recent publications from, I think, 2020 to 2023, yes. So, I guess the most recent one here is the one in Korea, yung ISOC-C. Ilang papers?
Tatlo na.
For 2023, in ISOC-C, merong 3 papers na na-publish. Yes, na na-publish, and then dalawang papers yung sa India, which is yung sa ABCAS. And of course, if you want to know more about these publications, all papers are accessible in the UP Microlab website, shown in the link. Ayan. Besides dun sa publication opportunities na meron sa Microlab, andito din of course yung travel opportunities. Na pinakita na nga namin yung map kung saan possible kayong makapunta when you publish. Ayan. And then, just yung most recent, yung sa India, yung nasa top right, ayan, Sir Chard and si Sir Arcel. And then, doon naman sa bottom left, yung pinaka-recent na ISOC-C. Ayan, with Ma'am Tess, Sir Chard, Ma'am Tata, ayan. And the undergraduate students na undergraduate students of Microlab. Ayan. For your application in Microlab, if you wish to pursue, ito yung mga required na coursework na kailangan nyo i-take. We have 2 courses. You just choose either one. If you wish to explore more on the analog and digital IC design, we have COE 197U for you. Ayan. This is a required elective, and this is offered every second sem. Meanwhile, if your interest is in MEMS, we have the introduction to MEMS. This is ECE 197U, also a required elective. But it can replace COE 197U for students under the MEMS topic. For the introduction on these courses, some of the topics that will be discussed will be shown later. Ayan. Another requirement when applying for Microlab is the paper reading sessions. Basically, we read papers, technical papers, and dito tayo dito tayo matututo to learn efficiently. Reading conferences, journals efficiently. I think when starting capstone projects, ito talaga yung isa sa pinakamalaking struggle for students, yung pagbabasa ng mga technical papers. And then Microlab, prior to the ECE 196, we will be offering these paper reading sessions during the 197U semester. Moreover, bukod sa pag-aaral kung paano magbasa efficiently, this will also teach you how to present in front of your advisors and the different graduate students. For the tool training, this is readily available, and if you wish to pursue Microlab, you will have access to the tools na, as mentioned ka earlier, these are tools na that industries mostly use na hindi siya na ituturo sa mga undergraduate courses here in Triple E. Ayan. To introduce you to the courses, we will start with COE 197U. Again, this is the Introduction to Analog and Digital IC Design. The prerequisites are si Triple E 41 or Triple E 131. This is anong course?
Amplifiers.
This is the course on amplifiers. I'm sure you will remember. Just seeing the numbers. 131. And also concepts from Triple E 51 or Triple E 141 will also be useful when studying this course. The coverage in this COE 187U is an introduction, of course. And then this will further delve into the difference between the analog and digital circuits. For the digital circuits, we have yung logic gates, NAND, or inverters. And then we have yung sequential circuits, which are latches. And then for analog circuits, we have yung op-amps, current sources. Again, in this course, we will be utilizing industry standard software tools. You will learn schematic entry simulation and possibly layout. Meanwhile, ito naman yung for ECE 197U, Introduction to Microfabrication and MEMS. Again, the prerequisite is Triple E 41 or Triple E 131. For this course, you will be introduced to the laboratory, the UP Diliman Microfabrication Facility. This is located in Triple M. And the coverage of this course are device microfabrication theories and processes, clean room operation, which includes yung laboratory safety, chemical handling principles, and fabrication equipment and processes. Also, yung principles of microelectromechanical systems or MEMS. Similar to COE 197U, you will be able to use industry standard software tools for modeling and simulation, and then for the actual design and layout. I think you will experience in the laboratory part of this course. So, just to show you yung different topics na currently ginagawa ng mga affiliates ng Microlab in the undergraduate, we have yung computing of, I think, yes, mahaba yung title, but, and you probably did not understand, but just to emphasize, the first topic is
AI
accelerators. And then the second one is on hyperdimensional computing. And then yung last one is in-memory computing. Ayan, these are the topics that are being explored on the digital side of Microlab. Ayan, for the MEMS and analog, we have yung first one is yung piezoresistive na pressure sensor. And then the second one, saw temperature sensors. This is under MEMS, and then the last three bullets are under yung analog part ng Microlab. The first one is yung LNI 8 to ADC na interface. While yung fourth ay yung LNI 8 low noise instrumentation amplifier, and then the last one is ADC. I think for the last three bullets, you may be wondering kung bakit yung third point is combines both LNI and ADC, while yung last two, yung pinaghiwalay sila, they are different projects, but for the LNI ADC, I think this depends kasi on the number of members actually. So the advisors, as well as yung other graduate advisors, will help you to determine kung ano ba talaga yung topic na appropriate when you already form yung groups nyo within Microlab. Ayan, for the last part, may we call on Boggs, we will be interviewing some of the Microlab affiliates kung bakit sila sumali sa Microlab.
Hello. Ayan. Parinig ba ako kahit dito ako? Dito. Okay. Hello. So yan, now we ask the question now, why did you join Microlab? I think magandang makuha natin yung perspective ng mga nasa Microlab na mismo. So siguro let's start with myself muna. So why did I join Microlab? Yeah. So actually, yung nag-present kanina is si Ralph. Ako yung tinuturo niya kanina na kagrupo niya. And actually, we just graduated recently, batch 2019, and currently taking graduate studies ngayon sa under Microlab pa rin. And yun, why did I join Microlab? I guess noong una, we're actually pandemic babies. Yan. So if you're going to do the math, I guess, yung triple E131, this nag-coincide siya dun sa first sem na nagkaroon ng naging remote learning talaga, which actually sucked din kasi parang sayang. And actually nung triple E131, I think yung latter part pa, which is yung mga small signal models, if familiar pa kayo, yung mga undergraduate natin dyan, nag-coincide pa siya dun sa bagyo nung panahon na yon. So actually, siguro most of the time, nagbasa na lang ako ng libro ni Razavi, kung naalala niyo yun. Pero I guess why did I join Microlab? So yung interest ko talaga, I guess, aligned with that. Yung 131 subject, which is actually nag-GA din ako ngayon, it's something na nagustuhan ko. And yung 141 na subject, actually, parang siyang parang sequel, which is actually something that I liked in that time. So why did I join Microlab? Another thing na gusto ko rin i-emphasize about Microlab is that personally, I'm a bit of a crammer. And the thing is, in Microlab, matututo kang hindi mag-cram. Yan. Hindi mag-cram. Yan. Well, bakit? Bakit hindi ka magkakaram dito? Kasi the thing is, yung pwede kong masabi talaga sa inyo na sure ako is that your advisors, yung graduate students natin na mag-a-advise sa inyo, yung actual advisor, yung mga doctors natin dito na mag-a-advise sa inyo, tutok talaga sila. Such that, let's say, every week, meron tayong meeting, ganyan. So you have to prepare and you will be criticized, syempre. Pero the thing is, it will always be constructive. And in a sense, this will also improve your habits na, okay, since let's say every Monday, magre-report ako. So, tapos yung advisors ko available lang during the weekdays. So, hindi ako pwede mag-cram ng weekends kasi baka hindi sila mag-reply kapag chat ko sila. So, may ganung factor na kailangan, siguro by Wednesday, I'm starting to do this thing, ganyan. So, yun. Develop good habits. Tapos, the advisors themselves, napaka-considerate, mabait talaga. And, yun. So, why did I join Microlab? I guess, yun, parang combination siya of my interest, also aligning with the people within Microlab. And actually being a part of Microlab for about, I guess, 2 years na, magto 2 years na. I'm still happy to say na I'm still happy naman sa Microlab. Ayan. So now we ask ngayon yung dear, I guess yung ibang students natin dito na nasa Microlab ngayon. Let's hear from a mas older na perspective. Ayan. Sige. Maybe call on Sir Renz. Dito na lang, pero pakinig ko.
Hindi, may mic naman. May speaker naman.
Okay.
So hello, ako si Renz. Ako si Rafael Bangilinan doon sa faculty kanina. So, why did I join Microlab? Actually, the reason niyan talaga. Sige, let's be honest first. The reason niyan is, no time na old curriculum ako. So, yeah, older perspective. So, old curriculum ako. And nung time na mag-a-apply na ako for a lab, ang nangyari is, chinek ko kung alin yung may yung pinaka least hassle na na-applyan. So, ang nangyari kasi doon, kung tinignan ko yung ibang lab, for example, noong time na yun for example, Bell, meron pa silang application process outside ng mga subjects. So, para sa akin, ayoko na ganun. So, nung nalaman ko na si Microlab, you just have to take the elective, tapos yung elective, credited pa siya. So, sabi ko, okay, perfect. So, Microlab. So, nag-apply ako sa Microlab. Actually, yun talaga yung main reason bakit ako nag-apply. But then again, nung nasa Microlab na ako, isa sa mga siguro pinaka-natuwa ako na culture sa Microlab is yung pag magkakasama kami sa lab lang. Basta tutulungan lang, tatanungan lang kami. Parang, nung time ko kasi, uso yung overnight sa Microlab. Tapos parang, halos, siguro 5 days, naka-overnight lang kami sa lab. Tapos magkakasama kami doon, nag-simulate. Yung aming mga circuits. Okay. Pero ayun, it was fun. It was a fun experience. At the same time, parang I can say na nag-grow din ako both sa academically and personally. Kasi nga, I get to interact with other people, diba? Tapos different kinds of people pa sila. Noong time na sinagrad ng undergrad, wala akong org. So yung opportunity ko to interact with a lot of people is doon nagkalaro ako. So doon ako nag-develop din talaga. Socially din, nasa Microlab. Tapos, mukha naman nag-enjoy ako kasi nasa Microlab ko din. So, ayun.
Ayan. Thank you, Sir Renz. Sige, isa pa. Can we hear from either Sir Fred or Sir Arcel? Kasi interesting din to kasi actually, Sir Renz kung mag-take kayo ng Microlab, actually Sir Renz is will be your instructor din for your laboratory. So, tapos either Sir Fred or Sir Arcel or the COE 197 yun naman na part. So, pwede ba?
Hello, hi guys, everyone. Sige, bakit nga ba ako nag-join? Sinagot ko na to last year eh. Pero sige, to answer na lang din yung question, nag-start siya kasi required course yung EEE 41. So EEE 41 is more on semiconductors. And merong siguro notion sa buong EEE that time na pag nag-41 ka, isa yung sa pinakamahirap na subject. Kasi yun yung parang gateway mo to all the other undergrad courses or subjects. And yun nga, medyo mahirap siya, but really, if you maybe read yung book and maybe attend lecture classes, I think medyo, sige, in essence, like na-enjoy ko siya kahit na medyo mahirap yung subject. So doon talaga nag-start. Then 41, tapos we also took yung 51, which is more on amplifiers. Although, nung nag-190 or nag-capstone project na ako, more on digital circuits talaga yung tinitig na namin. And siguro nag-stem yun dun sa courses ko naman, kay Sir Adel. Triple 105, computer organization. So mostly interest talaga siya. And well yun, parang nag-stay din ako sa Microlab kasi, well, nag-enjoy ko yung capstone project namin. Enjoy ko siyang gawin. Eh, siguro gusto ko lang din i-further yung parang knowledge ko or yung studies ko. And yan. So, ngayon, I'm currently taking my MS. Ay, ma'am. Finishing. Sige, ma'am Tess, ma'am Tata. Yes po. Currently finishing my MS. So, yeah. So, bigay ko yung mic kay Arcel. Kasi siya yung yung instructor. Oh.
Okay, hello. So, ako si Adel. So, why did I join Microlab? Actually, nag-start kasi yung curiosity ko dun sa nung undergrad kasi tayo, nung parang what ang ideas na may mga labs para dito sa Triple E, di ba? Parang magugulat ka na lang, may orientation tong mga ano tong mga orientation na to. And then even before that, kasi na magkaroon orientation, third year, so all curriculum, since 5 years course with Triple E, third year ako parang nag-explore ako ng Triple E website kasi hinahanap ko yung curriculum ng ECE. Dahil parang kinakalculate ko kung ilang years ako may extend dahil binagsak akong subject. so actually, nung sa yun, binagsak ko talaga yung subject na yun. And then habang ina-explore ko yung curriculum kasi, nakita ko yung mga research labs doon. Sabi ko, ano itong mga research labs na to? And then doon ako na-curious na i-click sa isa yung mga labs. And then you will direct yung mga ibang labs, kasi may mga websites sila. And then you can read yung kung ano sila. And then yung sa Microlab actually has one, di ba? Na actually ko dalawa lang ata yung labs doon na may website. And then actually na-curious ako. So parang ito pala, may ganito pala ganito. And then sabi ko, paano ko makapasok dito? And then sinerge ko yung mga interest ko topics. So actually, I picked 4 labs from that website na parang, I think mga gusto ko pasukan. Actually, Microlab is not my top priority. So pang-apat ko siya. So ang una ko talaga is RAL. So Robotics Automation. Pangalawa is WASL. Pangatlo is PEL, Power Electronics. Ayun, pang-apat na si Microlab. And then actually kasi, in that sense kasi, ang pagkakalala ko dito is, ang tagal maglabas ng application si WASL at si PEL. Si RAL kasi is actually by invitation lang ata, yung pag-accept sa kanya. Kaya parang, ay wala, since 101 ko is din, mas nangawa lang. Sorry. And then actually, Microlab yung nauna na maglabas ng application, so nakapag-apply ako. And then, yung process ng Microlab dati is may interview. So parang nangyari nun, yung mga current graduate students noon, yun yung nag-i-interview sa mga bago papasok. And then, parang, sige, introduction. And then, isa sa mga nag-interview sa akin, parang sabi, na-give questions doon sa tanong na, ano yung mga labs na kinonsider mo? Since, kasi kinuwento ko sa nila na paano ko nalaman yung lab o yung mga research labs na meron sa Triple E. And then, na-enumerate ko yung top 4 ko. So, parang, yun nga, RAL, WASL, PEL, tsaka Microlab. So, 4 sa amin. Tapos, biglang sinabi ng interviewer, pang-apat na pala kami. So, bakit namin natanggapin sa Microlab? Siyempre, nakakaba yung tanong ngayon na on the spot ka. And then, doon ko na actually doon, at that point, after ko ma-realize na parang yung sagot ko noon is actually Microlab yung Microlab, ini-encompass niya lahat nung ginagawa ng ibang lab. On the microscale nga lang. So parang lahat ng mga topics, mapa-wireless man yan, mapa-power electronics man yan, mapa-automation man yan, kaya mong gawin sa Microlab. So parang yun yung naging turning point na, oo nga, so why not tuloy ko na lang to? Diba? So doon ata ako na hope mismo sa sarili kong sagot na parang ganito pala. So parang doon tuloy-tuloy na. So nakapasok na ako ng Microlab. And then ngayon, nag-masters na ako. Pero continuing, hindi finishing. Continuing.
Sabi ni Sir Z, na-pressure ako ni Arcel mag-Microlab. Ano pong comments mo dito?
Kasi sabay kami ni Z, actually. Sabay kami. And then same time sa kami, magkasunod lang kami. Basta ako nata siya na interview, tas ako. Yeah, yung time na yun. And then na-pressure, ba't ka na-pressure pa
Okay na. Ayan. So yan, sana may natutunan kayo sa perspectives ko, and sa perspectives ni Renz, ni Sir Fred, at ni Arcel. Actually, yun nga, like nabanggit ko kanina, if you choose to take the electives nga ng Microlab, which means na most likely magma-Microlab na talaga kayo for the 196 and the 199, sila yung makikita nyo. Yung mga mukhang to. Yan. yan. Sina Sir Renz again, sina Sir Arcel, sina Sir Fred. And yun, I guess maganda na rin na narinig nyo rin yung background nila and kung bakit nila pinili mag-Microlab and now decided to actually extend yung knowledge nila sa upcoming batch, which will be kayo, yung mga papasok ngayon. So yun, I guess you can also say na yung common dun sa mga stories natin is that, well, first one, meron talagang interests. May interest tayo dun sa microelectronics. And yun, like what I've said also, yung advisors natin dito, tutok talaga. So, hindi ka mawawala. You will always be guided. And the last thing is, madali lang mag-apply. Yan. So, you'll just have to take the electives, as mentioned by Anna kanina, yung COE 197U, if you choose to take yung digital or yung analog approach, or yun nga, yung ECE 197U, which will be more on the MEMS side. So yun, well, para din naman sa mga unsure pa, well, if yung gusto niya talaga madaling makapasok, so walang hassle or anything, tapos gusto niyo, I can promise you na mabait talaga yung mga advisors. Then maybe, pag pumasok na kayo, mas mahalin nyo na yung Microlab. May ganun. So, so maybe you'll grow to love din yung inaaral nyo. And yun, siguro syempre yung orientation na to is more of to invite you rin and to invite you and let you know kung ano ba yung ino-offer namin. And yun nga, for the upcoming semester, since malapit na yung reg period, ganyan, hopefully, we have convinced you and mag-enlist na kayo. Yun na. So yun. So yung next natin is the Q&A section. So we'll be taking questions with the undergraduates na nandito ngayon and yung undergrads naman natin na nasa Zoom din. So we're open for questions now. Anyone? Wala pa. Wala nagtatanong. Sige, sir.
Ano kayo, workstation. May sinend si Alan kay Ena. Ano, picture ng workstation.
Sige.
Okay.
Oo. Okay. So, since wala pang nagtatanong, yun, meron na. So, anonymous participant, wow, pwede pala yun? Sorry. Anonymous participant would like to ask if I will take if I will take the ECE 197U as my elective, will that restrict my thesis topics to just MEMS? Thank you po. Hindi. The answer is no. No? So,
Why?
Ha? Bakit no?
Sige. Siguro hindi naman ma-restrict lang talaga sa MEMS. Baka i-encourage lang na mag-MEMS since yung background is on MEMS. Pero given naman na meron tayong mga paper reading sessions, so baka doon din mas makita na mas gusto pala yung either analog or digital na circuit design, pwede pa rin naman. Ang mangyayari lang is magkakaroon lang ng siguro additional training and baka magkaroon lang ng catching up na kailangan gawin para syempre makapag-keep up once come 196 and 199. So yun naman yung, pero ayun ideally kapag mas aligned sa elective na tinig yung magiging topic. Pero hindi naman siya strict.
Ayun si Ma'am Tess.
Ay, nasasagot daw si Ma'am Tess, di ba? Dito sa Microlab, kapag dito ka nag-196, alaga ka dito, you not only have 7 faculty advisors, nandun rin lahat ng grad students sa program niyo.
Interesting yung question, no? Kasi actually yung project namin sa CIDR, yung project 2, is really on co-designing the MEMS sensors with the interface circuits. So, kung nakita niyo yung mga projects kanina, nakahiwalay yung MEM sensors na mga projects, nakahiwalay yung interface circuits. But ideally, ang gusto talaga namin is a combination of students nung dalawang electives na yun so that they can really work on the integration of the two. So yun, malay nyo, mas doon kayo. Thank you.
Pwede po bang pumasok ng digital kapag nag-MEMS? Why not? Di ba? Okay, tapos anonymous participant number 2. Any tips/insights for me na interested in Microlab pero just finished 131 where I didn't do the best sa latter half niya. And I will only be taking 141 next sem. Tips daw. Well, actually, for me, ang maiisip ko doon is, makikita mo ulit yung concepts ng 131 pagdating mo ng 197U. No? And at that point kasi, mas small class na siya. No? So medyo mas alaga ka naman in the concepts. No? Meron ba dito ano? Sige, okay. Yung hindi nyo gusto yung 51 nung una. Kaso nag-microlab kayo. Ikaw?
Hindi naman kasi hindi gusto. Hindi ko siya ayaw, pero hindi siya yung favorite subject. Ganun. Pero, yeah. So, hindi siya yung favorite subject ko. So, parang, ano siya, parang, sakto lang. 21. Pero, siguro, tips na lang. One, huwag ka matakot na mag-take ng elective. That's one. And two, huwag ka matakot na mag-microlab. Because ang important naman kasi is that one, yung 131 na ibigay niya sa'yo yung fundamentals na kailangan mo para mas maintindihan yung topics na ituturo doon sa electives. And kung mag-capstone project ka sa Microlab, then you have the fundamentals needed. And at the same time, yung naman elective, one of the main purposes din is to reinforce those topics or those fundamentals. Para pagdating ng 196 and 199, mas equipped ka na gawin yung research work mo for your capstone project. So I think lang naman siya, as long as do the requirements sa elective, sa iti-take mo na elective, and ayun, try to understand din talaga yung concept na ituturo ng mga instructors doon sa elective, then kaya naman yun.
Alright. So, okay. Ito, interesting question. Paano po pinipili yung mga magiging topics and yung groupings for the capstone project? So, na-mention yung paper readings kanina, di ba? In the course of these paper readings, magsisimula siya with general readings, tapos magiging specialized yung readings. The thing is, sa Microlab, it's what happened in the last 2 years, no? Kaso magpo-provide kami ng general topics, tapos hindi siya irarapol. Pipili kayo para siya CRS draft. Kapag sumobra na doon sa expected number of students doon sa topic na yon, either magduduplicate yung topic or you guys will have to choose other topics, no? Yung nag-duplicate ng topic, I'm pretty sure nangyari sa din sa MEMS, right? December, no? So, ganun siya nangyayari. So, you actually will have already a general topic and your group mates by the end of COE 197U kapag ginawa namin yung kapag na-hold natin yung paper reading sessions, no? Okay, so so the next question is there a limit to the amount of students that can be accepted in each of the classes? Most of the schedules conflict po kasi with the other classes in our curriculum, so we can only enlist 1 or 2. But what if there are no more slots in those? ECE 197 yata, no? May nilabas na po ba tayo?
Wala pa.
Wala pong sinabi eh.
Sorry, alin yung may conflict ka, tapos alin yung tina-target mong elective?
Zero slots available na yung ECE 197.
Oh, yung ECE 197U is available na siya sa zero slot na.
Yeah. Yung buo yung 197 yun.
Yung sa ECE 197U, pwede naman mag-waitlist. So we will be able to check if yung mga nasa waitlist actually attended today's orientation. So it will be prioritized. Yung POE 197U enlistment is manual. So gagawin yan during the registration. And ito double check actually namin yung mga mag-waitlist against the attendance today. So priority yung mga nandito today dun sa pag-enlist. And then depending on the demand, we can decide to expand yung slots or add another lab class. So that's still going to be decided come registration period.
Ayun na. So, kung nandito ka today, please don't leave yet kasi picture na namin. No? Mag-picture taking tayo para malaman natin kung sino yung nandito talaga. May question si Sir Z. Si student Zyril, di ba? What should we expect sa COE 197U? Sir Arcel. Oh, by the way pala, no, yung dalawa nagsalita kanina, no, si Sir Arcel will be handling the analog lab part of 197U and Sir Fred will be handling the digital lab part of 197U. Tama ba? Maybe daw. Oh, sige.
So what to expect sa elective na COE 197U? So as the course's title suggests, yung introduction to digital and analog design, IC design. So you will learn both digital IC circuits at analog IC circuits in terms of we will introduce doon sa lab o sa component na part yung transistor characterization based doon sa models na meron tayo o sa technology na meron tayo, as well as yung how to build circuits from those transistors. So sa digital is yung normal na nakikita ng mga inverters doon sa mga courses nyo, sa mga digital courses nyo, and then doon sa analog is to how to build amplifiers. Doon naman sa nakikita nyo mga amplifiers doon sa EEE 131 and 141. So yun.
Right, so yun daw. Ayun, so hopefully that also answers the okay, so ano naman daw yung i-expect namin sa ECE 197U?
Okay. ECE 197U, siguro ang mas i-expect sa ECE 197U is more on the fabrication processes. So ituturo yung kung paano ginagawa yung mga microelectronic devices, more particularly yung mga MEMS devices. Pero dadaanan din ng konti yung mga fabrication processes for CMOS devices or yung mga transistors. And at the same time, siguro one of the highlights din ng ECE 197 is yung lab component niya, wherein the students will be able to work in UPDMF, which is actually a microfabrication facility here in UP. So yun yung isa. So actual na from yung magandang part doon is from the lecture na discuss yung theories ng mga fabrication processes. You will see them in action pagdating sa lab. And you will be the ones performing. So siguro yun yung magandang highlight. Or yun yung mas pwedeng i-expect natin from ECE 197. And additionally, syempre, i-discuss din yung principles ng MEMS and kung paano nag-design ng MEMS siguro dahil nga yun ang mas magagamit natin pagdating ng 196 and 199 na semesters.
Alright. Tapos, okay, just an aside, no? So, meron pa tayong questions, but naka-share sa screen ngayon, hindi sa screen namin, no? But, sige, this is like, this is like selling hard now. Kaso, kaso may magandang PC dun sa dun sa undergrad room ng Microlab. There's like 30 PCs there. Oh. Tapos ilan yung aircon dun?
1, 2, 3, 4, 5, 5.
Oh, di ba? May tubig din, oh, di ba? Kaso wala nakalagay doon ngayon.
Ay, maglalagay tayo.
Ayan, so yeah, it's just a pretty life up there in 403 as the people who are already there. Okay, tapos okay. So next question is, would there be any programming involved in Microlab? So I think Sir Adel.
So chances are, I'm Alan. Just in case you don't know my voice. Chances are that if you end up in one of the digital topics, you'll have to develop some sort of, let's say, accelerator. Kagaya ng current topics ngayon. So, some of them will involve dealing with AI. Okay, so if you're planning on taking the digital part, it's going to depend on the topic that you get, but we may recommend that you take COE 111 if offer siya next year, and or COE 168. Okay, just so you have experience with Verilog. For the AI topics, you already have experience working with Python, so there's that. You're practically ready there. For the HDC topics, I think they also work with MATLAB. Right? So yeah, so there's also that. And if you're planning on, well, if you end up working on the RISC-V processor topic, you will be expected to code in C and assembly. So if you liked what you've gotten out of C from, let's say, your 158 course, then you can go here. Please go here. So Verilog is a hardware description language. Basically, it's telling, it's different from programming languages since you're actually telling, let's say, your synthesis software, what kind of logic you want to put, let's say, on an FPGA or a chip. Okay. So,
and so hopefully that answers your question. Basically, by the way, no, Sir Alan, Sir Fred, and I are part of the digital part. No, so the topics that Sir Alan was talking about are found in the digital portion of Microlab. No. All right. So with that, that's actually currently the last question here. Okay, so mga undergrad na dito right now, hello? May questions pa kayo? Sige, ano. So ngayon nandito kayo, do you have any other labs in mind? Di ba yun muna?
By the way, in case you're not really sure if you want to go to Microlab but you're interested, you can always take COE 197U, and then after you take COE 197U, or maybe after you go through the paper reading sessions, you can decide if Microlab really is for you. So our lab comes with an extended trial period.
That is true.
By the way, TUI 197U and ECE 197U count as triple electives. So you can use them for that purpose too.
Hi, third club.
Executive summary of what just happened. Sorry. May nagtanong no, about conflicts, no? So apparently there are for third year first sem people, no? Marami daw ang nagko-conflict with the COE 197U. Apparently it's like triple E 192, which is actually the prereq for 196 and 199, right? Yeah. So, ayun. If you have any concerns about the yung conflicts na yun, no? So kung may nagko-conflict talaga na third year first sem subject with yung elective ng Microlab, then pa-email na lang po sa kay Ma'am Tata or kay Ma'am Tess, mga sa mga yung specifics po kung anong court yung nagko-conflict kina Ma'am Tess. Nakapag so
Would there be any program? Yes.
alright, so with that, sige. So pa-end na yung orientation. Kaso, sige, for last, no, may request si Sir Z. Request of sorts, no? Sabi niya, dapat pala tinanong nyo si Sir Adel kung bakit siya nag-Microlab because it's a funny story daw. Sir Adel, would you be willing to indulge?
Kailan ba yun? So yung main reason is just because may crush ako. May crush ako. Anong year na ba ako na? Late ako nag-apply eh. Kasi hindi pa ako makapag-decide na kung anong lab. Tapos nakita ko yung yung parang listahan ng mga recent applicants ng micro na-accept. Nandun yung pangalan niya. Yun na yun. That's the calling. So nag-apply ako. Tapos, I think kasabay nung application yung pagkuha ko rin ng COE 111, which was also a subject that I liked the most. So, na-enjoy ko yun, and since under ng micro yun, nagtuloy-tuloy. Tapos, tapos parang during yung, bago ako graduate ng COE na degree ko, I was involved in different micro related projects. Tapos sumisweldo ako eh. So may pera. Diba? So may pera. So tinuloy ko na, diba? So noon pa lang. So yun. Pero that's the main reason. By the way, hindi siya tumuloy. So natanggap niya ako sa micro, tapos nasaan siya? Wala. Lumipat na ibang lab. Pero nandito na ako eh. Mahirap bumawi, diba? Oh yan. Yan yung point.
Okay. Truly a story of all time. Sige, okay. So, to end things, tara picture tayo. So, ano ba? Paano natin yung atin to? Lagay ko yung laptop ko sa harap. Tapos iwalay na lang yung picture nung nandito. Okay, sige. So, everyone currently online right now, maybe request na okay, so mag-open kayo ng camera for us to take pictures. Oh, undergrad.
Undergrad.
Di ba sa kanya nanggagaling yung audio?
Ayun. Ay, isa pang undergrad, do.
Oo nga. Bakit may nakalagay na analog devices na? Tapos dalawa.
Ayun.
Ayan, so, sige. Okay, chat na po. Okay, 3, 2, 1, see. Yes, man din ako. Ang hirap mag-screenshot. Ano ba shortcut sa ng full screen? Control Shift Command.
Control Shift Command. Lahat yun.
Oo.
Command 5.
Ang dami na sa'yo.
Ano ginagawa ko? Ayan.
Ayan, naka-game.
Ayan, tapos, Shift Command 5 ulit.
Yeah.
Yan, yay!
Anong lumalabas? Okay na, okay na.
Okay, sige. So, thanks po everyone. Bakit may naka-neutral face? Sige. So, with that, sige, ends our orientation. Thanks everyone for attending. And hopefully we see you guys again in COE 197U and ECE 197U. Bye-bye.